Hey, Grayson. Hey, Sophia.
Hi.
Y'all this morning.
Hi. Tired.
Amen. Amen and amen. Good morning, Eli. I hear you. I'm tired too. But it's finally a spring day. At least that part's good. I was ready for spring.
I'm ready for summer.
Oh, well, yeah. Same. All right.
Hey, Sparks.
Yes?
I had a question number 13 because I finished my homework, but I didn't know what to do if there was no C.
Okay. Great question.
Because I got x equals 0
I'll
and
just
y
jump
equals
to
-3.
Yeah, I'll just jump to that one and then I'll go back and cover some of the rest of it, but I'll get this one taken care of. When there's no C like that and there's no B, you could still solve everything exactly as you normally would. But you're just going to end up, if you think about it, you're just going to end up with your the origin as being the vertex. So like if you added +0 for your B and +0 for your C, and then you solved for opposite of B over 2A, if you just solved it like we normally would, you'd have 0 over 2A. So that's going to be for your X. So your axis of symmetry is going to be X equals 0, like that. And then for your vertex, if you plug in that 0 back into the original equation, you're still going to have 0. So that means your vertex is going to be 0, 0, or the origin. So basically, and this one is negative, so it goes upside down, and you'd put your little vertex like that. Does that make sense?
Well, I thought you squared the 0. Oh,
And
wait.
0 times 0 is 0.
Yeah. Okay. That makes sense.
Like that. I didn't show all my steps. You caught me. But that is correct. Yes.
Okay, thank you.
So, yeah, no problem. You could solve it. You could go ahead and solve it. We've kind of algebraically proven that. But now, from now on, Sophia, if you remember that when there is no B and there is no C, if you want to, you can actually remember that means it's always going to be on the origin. Quite technically, this literally is just almost what they would call, they have a parent function for a quadratic, and it looks like that. And that means it would start on the origin and look just like that. And what happens when you multiply it by a -3 is it inverts and it gets skinnier. So it would rise quicker. And I know that was a lot of information I just spewed at you, but that's kind of a special, this is kind of a special form of a quadratic. So great question. But you finished all your homework?
Yes.
Oh, that's awesome. So it wasn't too bad?
No, I actually kind of like it.
Oh, good, good. Good job. Love to hear that. Awesome. Well, you did great. And that was a great question because this was definitely different. So, obviously you can work it out algebraically every time. But if you want to remember when there's no B or C, that the vertex is on the origin, that's fine with me too. A lot of times when we prove something algebraically and it ends up being not just a theory, but kind of a law that you can use every single time, I'm okay with you, just using the shortcut if you like.
Okay.
Okay. Great question. All right. Eli.
Can you leave that up there for 0.2 seconds longer?
Yes, absolutely.
Thank you.
You have anything else, Sophia? Did she leave me?
Yeah.
Oh, okay. Ruthie, good morning. Mary Faith, good morning.
Good morning.
Annabella came in and came out.
I got it. Thank you.
Uh-huh. All right. Did anybody else have a specific question, or do you want me just to start at the beginning?
Starting at the beginning will be fine for me.
Okay. Anybody else? All right. The first 5 questions came straight from the notes. Did everybody pick up on that? All you had to do is copy down the answers that you got from the notes, okay? So I'm going to let y'all just get those from the notes. Is there anybody who did not get the notes that's in Math Lab? Okay. Then I'm just going to start with number 6 and move forward. The first thing that we want to do is do the axis of symmetry. And remember, I'll go ahead and fill that one in. The axis of symmetry always uses this particular formula, the opposite of B over 2A. So you want to find what your B is. What's your B for this one? Any volunteers for the value of B for number 6?
Yes, 6, but I'm not really sure.
That is correct. Because remember, the format, the standard form is y equals ax squared plus bx plus c. All right. So wherever this is the b, whatever that number is, the coefficient on that middle term, as long as it's just an x, that's the b. So what's the a?
1, maybe?
Yeah, it is 1. The understood coefficient on that one right there. Okay. That's your b, that's your a value. So x equals the opposite of b over 2a. What is the opposite of b in this case? If b is 6, what is the opposite of 6?
Negative 6.
Yes, -6. Good job. Over 2 times a, which is 1. So that's -6 over 2, which is -3. So x equals -3. So to find the vertex, we plug in -3 back into our original equation. So y equals 9 minus 18 plus 4. So -9, 9 minus 18 is -9, and -9 plus 4 is y equals -5. So my vertex is -3, -5.
Okay, what's super funny is that whenever I come and join Math Lab, I always understand how to do it, but like in class, it just doesn't make sense. Like we've just done one example problem and it makes so much sense.
Oh, well, maybe you just need to participate more in class. Maybe it's because you're participating. I don't know. Maybe this is just the best learning format for you. So it's a good thing we got Math Lab, right?
Yes,
because you always I was like, you always rock Math Lab. Okay, so what is B for number 7?
8.
Good job. What is A?
-2.
Right. So X equals, what's the opposite of b?
-8.
Over 2 times -2. Is everybody understanding why I did it this way? Remember, we're just plugging in. You figure out what B is, you figure out what A is, and you put those numbers back into the formula, and you use that same formula every single time. So now I've got -8 over 2 times -2, which is -4. And -8 divided by -4 is a +2. And so now I've got my axis of symmetry. And now I'll take that x equals 2 to find out my y coordinate for my vertex.
But the one thing that doesn't make sense is the sketching part. Like when you have to draw the diagram.
Yeah, I kind of understand that a little bit. It'll make more sense when we apply the whole thing to the coordinate grid, I feel like. But when I draw this next sketch, I'll try to explain why we do it the way we do it.
Okay.
And unfortunately, I'm gonna have to rewrite this right here. You think you have enough room? I'm like, wow, I'm really gonna have enough room to write everything this time. And then it just never quite rolls out like that when I'm drawing. So I have y equals -2 times 4, because I've squared that 2, plus 16 minus 5. So -2 times 4 is -8, plus 16 minus 5. -8 plus 16 is 8, and 8 minus 5 is 3. So my y coordinate for my vertex is 3. Now, what I want you to understand in the sketch is this imaginary line is the axis of symmetry. That's x equals 2. And it splits the parabola in two. So, and this one is going to be a frowny face because it's a negative leading coefficient. And you want this dot right here that's supposed to be the vertex. It will be on that axis of symmetry. And I just want you to get used to the fact that there's just a dotted line with a cup on it, either going up or going down. Okay?
Wait, why is it going down? Like, why is it negative?
Because remember, if the leading coefficient, what's the leading coefficient on this? What's the A?
Oh, I see. -2.
Yes, if it's negative, it doesn't matter what the coordinates of the vertex are. It matters what the leading coefficient is. That gives you your direction of up or down. So in this particular lesson, what we're learning is that there's an imaginary line called the axis of symmetry that splits this cup or this parabola into two equal parts. And the second thing we're focusing on in this lesson is the vertex or the tip of that cup is either going to be the highest point or the lowest point of the parabola. Okay? And that's the focus that we're learning. The next focus is going to be when we put it on the coordinate plane. So if I was putting this graph on the real coordinate plane, I would count over 2 and up 3, and my vertex would be right there, and my parabola would look like that. But for now, I just want you to focus on getting the cup going up or down and learning that that axis of symmetry splits the cup, splits that parabola, okay? We're just taking it one step at a time. Tomorrow in class, we're going to learn how to put it on the coordinate plane. But for now, we're just learning there's an axis of symmetry. There's a U-shaped parabola, the parabola, and we're learning whether it's going up or whether it's going down. We're going to learn how to apply it to the coordinate grid tomorrow. Does that make sense? A little bit or no? We're just baby stepping through this thing because we know what we understand from working with this in the past is it's just easier to take it little by little when it comes to graphing. It's kind of like when we introduce fractions, believe it or not, we go really, really slow when we introduce fractions in elementary school, but it just doesn't feel that way, I don't think, to you guys. Anyway, does that help a little bit with understanding the graph, Grayson?
Maybe, kind of, yeah.
Okay. What is confusing for you about the graph?
No, I guess it makes sense. It's just weird.
Okay. Okay. So, all right. So what's the B on number 8?
-2.
All right. What's the A?
1.
Good job. Does anybody else have any questions while I'm going through this? Oh, Ruthie answered in the text. If somebody answers in the text, I can't see the text, so I would need somebody else to let me know that somebody's talking to me on the text box. Because when I have this pulled up, when I have the worksheet pulled up, I can't see if y'all are talking. Anyway, but yay, thanks, Ruthie. That was probably back quite a while ago. I just check every now and then. I try to go back and forth to the other box so I can see who's on, see if anybody has questions. But Grayson, you'll have to be the spokesperson.
Yippee.
Okay, x equals, so now we have a B with a -2. All right. So that -2, what's the opposite of -2?
+2.
Good job. So our B is +2. Our opposite of B at the top for the numerator is 2 because the value of B by itself was negative. So now we've got for our denominator 2 times 1. So x equals, and then 2 over 2 times 1 is 1. Does everybody see where I got that? Or did I shortcut that too much? Do I need to show that work? 2 over 2. X equals 1. All right, so now I'm going to plug in. I'm sorry?
Never mind.
Okay. I'm going to plug in my 1 to my formula and solve. 1 squared is 1. 2 times 1 is 2. So the y coordinate for my vertex is -1. So my sketch is this imaginary dotted line that will split my parabola in half. And I'm going to check my leading coefficient. It's positive, so I'm going to have a smiley face parabola. With a vertex at 1, -1. And that axis of symmetry is x equals 1. All right, what's my B value for number 9?
-8.
-8. What is my A value?
-1.
-1. Good job. X equals, so what's the opposite of -8?
Positive 8.
Positive 8 over 2 times negative 1. So x equals 8 over 2 times negative 1 is negative 2. 8 divided by negative 2 is negative 4. So my axis of symmetry is x equals negative 4. I'm going to plug in that negative 4 back into the original equation. To find out my y coordinate for my vertex. Negative 4 squared is 16. Negative 8 times negative 4 is a positive 32 because a negative times a negative is a positive.
And shouldn't that 16 be positive?
The 16 inside the parentheses is positive, but there is a negative on the outside.
Oh, that's super confusing.
Basically, remember, see your A down here where you said it was negative 1, right? So what you're essentially doing is multiplying the results of what's inside the parentheses by a negative 1. Because you said your A was a negative 1, which was absolutely correct. So essentially, you've got a negative 1 as your coefficient of that x squared. So you can't forget about that negative 1. But your negative 4 squared is a positive 16 because a negative 4 times a negative 4 is 16. So you've got 16 times negative 1. So that's going to be negative 16 plus 32 is 16, and 16 minus 9 is 7. So my vertex is negative 4, positive 7. So I have an axis of symmetry of x equals negative 4. And which direction will my parabola go in? Will it be a frowny face parabola or will it be a happy face parabola?
Frowny face.
Frowny face, because if you look at that A or the coefficient on that A, it's negative. And this really should split the parabola. I'm just not a very good drawer. And that vertex is 4, 7. Are there any questions so far? Anybody have any questions?
Miss Sparks, real quick, can you scroll up to number 6 so I can copy down?
Absolutely.
Thank you.
I'm going to finish my artwork there on number 6 while we're there. Ruthie, don't judge my artwork. Any questions so far? Is this making more sense for you guys?
Okay, you're good. Thank you.
Okay. Mm-hmm. All right. What is the B value for number 10?
Negative
20.
20.
Good job. Good job, gentlemen. What is your A value?
-5.
-5. Good job. All right. So what is the opposite of -20? If we're taking
20.
the opposite of 20. Good job. All right. And then we've got 2 times -5. So x equals 20 over -10. X equals -2. Because 20 divided by -10 is -2. So I have an axis of symmetry of -2. So now I'm going to take that -2, plug it back into my original equation. All right, and see where I wrote down that -5? Remember in the previous problem where there was a wee bit of confusion because of the -1? Sometimes I was thinking about if you need to, when it's just a negative in front of the x, if you need to write like a -1 here to remind yourself that you're multiplying by a -1, you know, that's fine too. Okay? If that makes that a little easier for you guys. Okay, so I have y equals -5 times -2 squared, which is 4. And now I have a -20 times a -2. That's going to be a positive 40 minus 26. And then -5 times 4 is -20 plus 40 minus 26. Y equals -20 plus 40 is 20. And 20 minus 26 is -6. So my vertex is -2, -6. So my axis of symmetry, that imaginary line that splits the parabola, is x equals -2. And then is my parabola going to be a frowny face or a happy face? What is my A value?
It's going to be a frowny face.
It's going to be a frowny face. Good job. Because that A value is negative. The leading coefficient is indeed negative. So I've got a frowny face parabola with a vertex at -2, -6. Okay, what is my B value for number 11? Or is there one? Is there a B value? Is there an X variable all by itself in this?
I assumed it was -4, but now that I look at it, I guess that's wrong.
No, that's your C value, your constant. So this actually is y equals x squared minus 0x minus 4. Because there's no x variable. So my B is 0. My A is 1. So the opposite of 0 is basically 0. And then 2 times 1. Y equals 0 over 2. So y equals 0. Or x equals 0, my bad.
Why didn't you just put the 4 is the -4 is the B value?
Because it's the C value.
Okay.
Because the standard form is ax squared plus bx plus C. There's a constant on the end. There's 3 terms in a quadratic all the time. Even if they're not there, there's 3 places that's understood to be in a quadratic. So when there's no number there, you have to kind of remember that there's a 0 there as that place filler. Okay? Great question. So if there's only, like, I literally could have this right here, and that's still a quadratic. But there's a, and we did this with number 13, but I don't think you had gotten there quite yet, Reese. So it literally looked like this. So you've got that B value and you've got the C value. The B always has an X connected to it. If there's not an X connected to it, it's not the B value. Does that make sense? Okay, cool. Great question. Does everybody feel clear on this one? So your axis of symmetry is X equals 0. So now what we're going to do is plug back in that 0 into our original equation. And we have a Y value of -4 for our vertex. So our vertex is 0, -4. So our axis of symmetry is X equals 0. And our parabola, is it going to be a smiley face parabola or a frowny face parabola? What is the A value? Is it positive or negative?
It's going to be a smiley face.
Yes, it's a smiley face parabola. Good job, because the A value is positive. So we have a smiley face parabola with a vertex at 0, -4. Good job.
Okay, wait. Hold on. I'm so confused. I wrote something in the wrong place. Let me try and figure this out. I think I got it. Thank you. Sorry.
Oh, no problem. Just ask me questions too if I can help, okay? So what is my B value? On number 12, I'm sorry. What's the B value on number 12?
2.
Good job. What's the A value on number 12?
-1.
-1. Good job. And just as a reminder, one last time, remember we're looking for the opposite of B over 2A. Just to remind you guys that we're using that same formula, because I've been pretty directive in my questions of saying, okay, what's the opposite of B? So the reason why I'm always looking for the opposite of B is because that formula is X equals the opposite of B over 2A. So that's why I'm asking what is the opposite of B. So I'm looking for the opposite of B, which is 2 over 2 times -1. I just kind of want to remind everybody again while I've been directly asking that question so that that doesn't get, confusing and be like, oh, well, when we were doing it on math lab, I've been asking what the opposite of B is. So I wanted to make sure that y'all remembered that it was the opposite of B in that formula. So opposite of 2 is -2, and 2 times -1 is -2. So now I have -2 over -2, so that equals 1. So my axis of symmetry is X equals 1. So I'm going to go back in and plug in. Remember, my A is -1. I've got that negative there. So -1 times 1 squared plus 2 times 1 minus 4. Y equals -1 times 1 plus 2 minus 4. And then y equals -1 times 1 is -1 plus 2 minus 4. And -1 plus 2 is 1. Minus 4 is -3. So my vertex for number 12 is 1, -3. So I have this imaginary line called the axis of symmetry at x equals 1. And is this going to be a smiley face or a frowny face parabola? What is my A value? Is it positive or negative?
Negative.
On number 12, is my A value positive or negative?
Negative.
It is negative. So that would make it what type of parabola? Frowny face or a happy face?
Frowny face.
A frowny face parabola. Good job. With an axis of symmetry, with a vertex at 1, -3. Okay, I know some of you kind of came late to the math lab, so if you need me to erase number 13 and go over it again, I'm happy to do so. Is there anybody that needs me to do that? If not, I'm just going to move on to number 14.
I'm good.
Okay. All right. What is the B value for number 14? The B value for number 14.
-12.
-12. Good job. And what's the A value for number 14?
+2.
+2. Good job. So when we're plugging this into the formula, we've got the opposite of -12 all over 2 times 2. And because our formula is this right here, the opposite of B over 2A. So the opposite of -12 is +12 over 4, and x equals 3. Did I lose y'all? Is everybody still with me?
It's me, Eli, and Reese.
Okay, are y'all still good?
I'm good.
Did I say something that confused everybody because everybody got really quiet?
I'm fine.
Was it confusing? Oh, okay. All right. Now I'm plugging back in my value, my x value, to find my y value for my vertex. And 12 times 3 is 36. And then 18 minus 36 is a -18, plus 10 is going to give me a -8. So my vertex is 3, -8. So I have an axis of symmetry that splits the cup in half at x equals 3. And is this parabola going to be a frowny face or a happy face parabola?
Happy face.
Happy face.
Happy face parabola. Good job. With a vertex at 3, -8. Okay. Last one. The B value is what on number 15?
Ten.
10. Good job. Way to go, Reese. Okay, what's the A value?
1.
Good job. So we have x equals the opposite of 10. I kind of started feeling bad that I wasn't specifically putting that opposite thing in that formula from earlier. Is that okay? Is it better if I put in opposite to remind you that it's opposite? What are y'all's thoughts on that? Instead of just asking the question, what's the opposite of B? Is it better that I include it in the formula? Is that a better way to remember it?
I'm not really sure about other people, but it makes sense to me how you've been doing it.
Oh, okay. All right. Thank you for speaking up, Reese. I appreciate the feedback.
You're welcome.
And then 2 times 1. I just want to make sure everybody remembers that you're looking for the opposite. You know what I'm saying? So I don't ever want to cause any confusion with regard to that. So x equals -5. So I have a vertex of x, an axis of symmetry of x equals -5, and it is the x coordinate on my vertex. And to find the y coordinate on the vertex, I'm going to take that -5 and plug it back into my original equation. And then work that out. So -5 squared is a positive 25. And 10 times a -5 is -50. And 25 plus a -50 is a -25. And -25 plus 24 is a -1. So I have a vertex at -5, -1. So I have an axis of symmetry, this imaginary line that splits this parabola into 2. X equals -5. And what is this going to be, a smiley face or a frowny face parabola based on my A value?
A frowny face.
Look again. One more time. I know that the vertex is negative, and I get that, and that's where that's really confusing. But you just flip back and look at that A. So, yeah, I know you've got it. I know that you have it, but it really can be confusing when you have both of your coordinates and your vertex is negative. That just means it's going to start in a lower place on the coordinate plane when we plot it. But your vertex is at -5, -1, but it's still a happy face because your leading coefficient is positive. So there it is. Are there any other questions?
No, ma'am.
All right. Well, y'all have a blessed day.
You too.
Yeah, y'all did great in math lab. Thank you for coming.
Thank you for doing it.
All righty. Have a blessed day. Bye-bye.
Bye.
See you later.